Hello, my name is Clinton, and I'll be your guide through this second module of Day 3. We're going to talk about some more trig function identities called addition and subtraction formulas and double angle formulas. Please don't forget to pause this presentation at any time if you need a bit more time to think about something. Let's think about the following situation. We have two angles, say A and B, and we want to know something about the angle A minus B, given by the difference between them. You can see the setup that we're talking about drawn on this picture here. The angle A minus B is here. Any point of the form cos x sine x will lie on the unit circle because of the identity cos squared x plus sine squared x equals 1 that we saw in the last module. So we can label the x-coordinates of this triangle by the cosines of the angles and the y-coordinates by the sines of the angles. Here's the angle A minus B and the labels on the other 2 points in the triangle. Let's label the unknown side of this triangle C. We know both of the other sides have length 1 because they're radii of a unit circle. In general, in a setup like this, we can apply the cosine rule to calculate the cosine of the unknown angle. This gives a formula for c squared, as c squared equals 2 minus 2 cos A minus B. You should check that you can get this formula as well. So we have a formula for cos A minus B in terms of this unknown side C. It turns out that there is another way we can compute this. Let's form this smaller red triangle here, in which C is the hypotenuse. We can use Pythagoras' theorem to find c squared, provided we know the other 2 sides in the triangle. But these other 2 sides are just given by the differences in the x and y coordinates. So c squared equals cos A minus cos B all squared, plus sin A minus sin B all squared. Since this side here is just cos A minus cos B, the difference in the x coordinates, and this side here is just sin A minus sin B, the difference in the y coordinates. If we expand these squares out now, and use our familiar cos squared plus sin squared equals 1 formula to turn these terms into a 2, before we had c squared equals 2 minus 2 cos A minus B, and we just saw that c squared equals 2 minus 2 bracket cos A cos B plus sin A sin B. So equating these 2 expressions for c squared, cancelling and dividing by 2, we obtain this formula in the box here for cos A minus B. This is known as a subtraction law for the cosine function. It lets us compute the cosine of the difference between 2 angles. We can obtain other laws for sine and cosine, as well as tan, using similar arguments. Cos A plus B is cos A cos B minus sin A sin B. Cos A minus B, as we just saw, is cos A cos B plus sin A sin B. Sine of A plus B is sin A cos B plus cos A sin B. Sine of A minus B is sin A cos B minus cos A sin B. And there are 2 formulas for the tan function as well. Let's see an example of how to use these laws in practice. Suppose we have 2 angles x and y, and suppose we know the sine of x is 5 over 13, the cosine of x is negative, and we know that the cosine of y is 4 on 5, and the sine of y is positive. Let's use all of this information, and the double angle formulas from before, to find the sine of x plus y. Well, using the double angle formula, we know that sine of x plus y is sin x cos y plus cos x sin y. Since sin x is 5 on 13 and cos y is 4 on 5, sin x cos y is 4 on 13. We now need to find out what cos x and sin y are. Of course, if we know sine and we know whether cos is positive or negative, we can work it out, because cos squared is 1 minus sin squared, which means cos is plus or minus the square root of 1 minus sin squared, and combined with the information of whether this is positive or negative, this is enough to work it out. So if sin x is 5 on 13, and cos is negative, we must have cos is minus 12 on 13. Similarly, if cos is 4 on 5 and sine y is positive, we must have sine is the positive square root of 1 minus cos squared, which is 3 on 5. You should check that you can get these numbers as well. We can now piece together sine of x plus y from all of this information. Cos x sine y is minus 12 on 13 times 3 on 5, so sine x plus y is 4/13 minus 36 on 65, which, using a calculator, is minus 16 on 65. We can also use these formulas to find cosines and sines of twice an angle. We will see the general form of this in our so-called double angle formulas later. Let's do an example now. Suppose sine x is 5 on 13, where x is some angle between 0 and pi on 2. Let's use our formulas above to work out the cos of 2x. We can use the addition formula, because 2x is just x plus x. So cos 2x is cos x plus x, which is cos x minus sine x, or cos squared x minus sine squared x. Since sine x is 5 on 13, cos of 2x is cos squared x minus sine squared x, which is cos squared x minus 25 on 169. Now we need to figure out cos squared x. But using the most important trig identity of all, cos squared x is 1 minus sine squared x, which is 144 on 169. So cos of 2x is just the difference of these two things, which is 119 on 169. Try some of these questions yourself to get some practice with the addition and subtraction formulas. Press pause and then press play when you want to continue. Here are the answers. Press pause and then press play when you want to continue. As we saw above, using the fact that 2x is equal to x plus x, we can use the addition formulas and subtraction formulas to obtain double angle formulas. As we saw, using the formula for cos a plus b with a equals b, we have cos 2a is cos squared a minus sine squared a. We can add and subtract a cos squared a into this, which has no effect since we're just adding 0, and then further use our famous cos squared plus sine squared equals 1 formula to simplify this to cos 2a is 2 cos squared a minus 1. There's another way to write this identity. Pause and see if you can show that cos 2a can also be written as 1 minus 2 sine squared a. Press play when you want to continue. Now let's do a similar thing with our addition formula for sine. Using the formula with a equals b, sine 2a is sine a cos a plus cos a sine a, which of course is 2 sine a cos a. So sine 2a is 2 sine a cos a. And finally, let's find a double angle formula for tan. Using the addition formula that I've got written here for tan with a equals b, we see that tan 2a is 2 tan a on 1 minus tan squared a. Here are the double angle formulas then, as we've just worked out. Try some more of these questions to get practice with the double angle formulas. Press pause and then press play when you want to continue. Here are the answers.